I'm Filip from Flare. We have a huge booth down there. Guys are already waving. And what are we? Well, we are a blockchain for data. What does that mean? Well, Flare is a layer 1 EVM compatible blockchain. That's nothing special, but what is special? We have some native data acquisition protocols. What that means? Well, that means, what that means? That means that you can get on Flare, you can use your existing tooling. You can use Hardhat, you can use Foundry, you can use EVM chains, you can use anything. You can use Web3 authentication, you can use, as EtherSpot said before, account abstraction, but also you get access to the best decentralized Oracle currently available. So this is the FTSO, and this is one of our main prizes that is also available at this hackathon. And FTSO offers you a decentralized price information. It is operated by a staked network of validators. Currently, about 100 different data providers are providing independent pricing data, independent pricing signals directly on the network. This gets aggregated on the network, a weighted median is selected, and that means that at each point, at every second on-chain, your contract, your event collector, or pretty much any off-chain app can access this data. So that means that you have a full security of blockchain, full trustless capabilities, full EVM compatibility, together with a trustless price of Bitcoin, Litecoin, some stable coins, so you can see when they're crashing, all this directly on-chain. So this is the core protocol. We have a big bounty on it. And then Flare also offers additional data capabilities. Specifically, it is connecting different data sources from different blockchains using the state connector, which allows you to deterministically attest to off-chain data, both from Web 2 and Web 3. So that means that you can start on Bitcoin, do a transaction, and use state connector to move this transaction to Flare. And once you have it on Flare, you can use the FTSO, calculate the price of this transaction using the decentralized Oracle, and then use this in a smart contract. We also have F-assets coming on chain pretty soon. Those are multi-collateral backed non-smart tokens, so you can have a wrapped Bitcoin, as said before. And Layer Cake offering you bidirectional bridging of smart contract tokens together with cold data. So all this gives you a full EVM developer experience on a smart chain with low gas fees and enables you to build a bunch of stuff. So once again, an EVM compatible proof of stake network. We've adapted the Avalanche C chain nodes. So what that means you have a low block time, 1 second block time. You can do things immediately. You can reuse the existing Ethereum tooling, Hardhat, Solidity. You can use MetaMask to easily onboard users. That also means you get ERC20 tokens for free. We allow Web3 authentication, so people can sign in with Twitter, people can sign in and get access to the blockchain directly with their social accounts. We have multiple native NFT marketplaces, and of course, we offer a huge support for developers, providing a tooling and periphery and everything else you're going to need. Moving all this together, we are a blockchain specifically for data with the FTSO focused on DeFi. We already have a large DeFi ecosystem that you can plug into. We have liquidity on-chain. We have ERC4337 support directly from EtherSpot, like I said before. We have stable coins. We have all these necessary infrastructure stuff you need to build on-chain. We have great Oracle, and now we just need you to come, try, play around, and get some prizes. Okay, so let's take a look at what the FTSO system really is. So FTSO stands for Flare Time Series Oracle. What that means? That means we have a set of data providers, 100 currently data providers, are submitting a new price every 3 minutes. And every 3 minutes, the FTSO system on-chain calculates the median of this price. That means that even if a data provider is off, even if a data provider is malicious, even if they misbehave, they can't really impact the price that much. We have a system of delegators behind this, securing the prices completely. So the selected median is selected by a weighted median, so people can delegate their votes, get some rewards, and in that way secure the network. And once the price is selected, so we currently offer 18 different cryptocurrency prices ranging from Bitcoin, Litecoin, XRP, and stuff like this. Once the price is selected, it's emitted as an event from the FTSO system and also written on an FTSO smart contract. What that means? That means that any contract on this chain or any on-chain, off-chain application can easily query it, use it, and we also provide access to historical prices, and that essentially gives you ability to do some time-warped average pricing, some average pricing in between, some squaring and stuff like this, and see how the price is moving and really kickstart your DeFi abilities. Okay, a bit more technical. So like I said before, there's a commit period where all the FTSOs are committing a price to make things a bit more secure. They're then revealing them, and that means that every 3 minutes we get a fresh price on the system. And since there's a lot of competition and the Canary network has been running for more than 2 years and the mainnet is alive for more than a year, we can see that this game theoretic solution has really worked. A lot of different FTSOs distributed across the globe. We have FTSOs from Australia, New Zealand, we have South Africa, we have South America, we have the States and Europe. Means that even if an exchange falls down, even if Binance is inaccessible, even if a stablecoin detaches, the FTSO system is strong enough, is big enough, is resilient enough that the price is always correct. If you remember when a year and a half ago, CoinMarketCap started submitting some weird pricings, the FTSO system picked up on it, and most of the FTSOs immediately dropped this CoinMarketCap price source, and the data was always correct even when the prices skyrocketed to billions. So this ability gives us a really resilient oracle, and we want people to build on it. Okay, enough talking. Let's see how the code works. So you can scan this QR code, or you can just go to the URLs at the bottom. You'll get the starter pack. So we prepared some of the starter packs. Okay, let's go back. You all set? Did it work? Okay, so we know that the developer experience is important, so we've prepared starter packs. This one is a starter pack for Hardhat and TypeScript-based development, but if you go to the Flare's webpage or if you go to the Hackathon's webpage, we also prepared the starter kit for Foundry. As said before, we are a fully EVM-compatible blockchain. That means that all existing tooling is available, and what we're working really hard is to try to enable you to use this tooling together with our periphery packages to get things started. Okay, so you cloned this, and let's directly jump into the code. So this is just a clone of the starter pack with some additional data. And as said before, it's pretty standard. So we have Hardhat, we have Hardhat configuration, and as it suits a proper network, we have 2 different networks. So we have Flare mainnet and Flare Canary and Songbird Canary network, and we also have Coston and Coston 2 as test nets. They are always mirroring whatever is happening on Flare technology-wise. So if you want to test some product out, you can get to the faucet that is available for both of them, get some test tokens, try them out, and then deploy first on test networks and then on real networks. Let's just check this. Okay, so as said before, we have Songbird Canary network with all the necessary information you can use with a real token and with Coston testnet, and we also have the mainnet with the same technology and with Coston 2 testnet, which you can use to get things up and running. Okay, so let's just take a quick look at this and see how the FTSO system works. So we're going to start with the FTSOs. So each of the price pair, Flare currently supports 18 different price pairs, is set and calculated by a specific smart contract called the FTSO. This is a standard Solidity contract. They are fully published. Every code, everything we do, all the code we publish is open source, and they're fully audited. So each FTSO takes track of a current price pair, takes track of a historical value of this price pair, and takes tracks of all the calculations necessary. So you can see who voted for which price, what was their vote power. All this is registered by FTSO registry. Why is that important? Most of the time, you don't really need to access the full historical price. Most of the time, you just want to get quick access to some of the prices on chain and see what's happening on them. So most of the time, you're going to be using FTSO registry to just get a quick glimpse of the price. And then if you want to do any specific, you can use the FTSO directly. Okay, let's take a look. So here's the block scout. So all the existing tooling works. And we're directly at the FTSO registry. It's a proxy contract, so we can easily upgrade and check it. And we can see that here's a huge list of all supported FTSOs. But we don't really want to take a look at this. We want to take a look at the specific method and say, okay, let's get the current price. Which coin would you like to see? Huh? Ethereum, okay. Because we are on testnet, we have to prefix this with test ETH, just to make sure we never mix them up. Okay, let's query it. The data connection is a bit slow. And okay, we got back the price, and you can see that the price is not exactly right. If the Ethereum was that expensive, we would be probably doing something else. What actually happened is that we want a greater granularity than just a dollar level granularity. So each of the prices is currently available with 5 decimal granularity. That's not something we want to forget. So you really want to use the method get price with decimals, which allows you to also get this information and not price the users a bit too much out of it. So paste ETH. We query this, and another result. Just move to a different network. Okay, and we got the same price. We got the information about the decimals, and more importantly, we got the timestamp when this price was finalized. So if you do anything really important, you want to know when was this price valid. As I said before, we get a new price every 3 minutes, but inside of it, you want to know that, I don't know, just after the price is selected, it's a bit more reasonable. After that, you want to include some variance into your models and price them properly. Okay, so that's using the blockchain explorer. What do we really want to do? Well, we really want to get some code up and running and see how that works. To set this up properly, we also provide periphery packages. We're just going to take a look what's the most important periphery package, which is Flare periphery contracts. What that means, in the good old days, you had to go to the block explorer, copy the code out, go to GitHub, get all the interfaces out, hope you didn't get them too late, hope you copied them correctly. What we do now, we publish all these directly on the NPM immediately after a new version is released. So what that means, you can download this NPM repository. You can check custom 2, for example, maybe not mock contracts, custom 2, FTSO user interfaces, FTSO registry, and you got the full solidity file that is up to date with the current thing published on network. So what that means that when you're using something in a program, you don't need to copy this. You can rely on NPM to hopefully do this for you. And what that also means that when you're creating a contract and when you're writing something, you can just import this from the periphery contracts, and the Solidity will take care of the rest. So you don't need to worry if there's an interface mismatch. You don't need to worry if there's a version mismatch. All this is directly inside. Okay, so we got the necessary interfaces we need. And we also have some additional helpful library. What's this? Well, as I've shown you before, we have a bunch of contracts available on Flare. And it's always difficult to know which one is the right one. And to properly structure this, what we have done, we have created a library together with the mock contracts that allows you to query a specific Flare-approved contract directly on the address. So every time the contracts are updated, we also update the Flare address manager, which holds the addresses of all the necessary contracts. So be it FTSOs, be it FTSO registry, be it all the contracts related to being an FTSO, voting, and everything. This gets saved, and this gets saved into a specific contract that is used as an entry point. And as said before, the periphery package also has a utility folder with the contract library. that gives you type-safe version of these addresses. So what that means, every time you need to access Flare FTSO registry, you just use the periphery contracts, get the registry. This will query the Flare contract registry on-chain directly. So it's only a view method, and the whole library is huge, but it will get optimized by the compiler away. So it will get properly inlined, and you will always be sure that you'll get the correct data. Okay, so that's all the necessary intro we need to have, and let's see how the code looks. Okay, so what we're doing here, we know that we're an EVM chain, so let's create a simple ERC20 contract. What that means? Well, we're creating a token, and we want users to be able to buy this token. And how are they going to buy it? Well, let's say we're going to allow them to deposit some Flare directly on our token contract, and we're going to mint some tokens to them. And of course, we could mint 1 token per 1 Flare. We could mint 10 tokens per 1 Flare. We could mint whatever we want. But we're going to do it differently. We're going to say, OK, for every $10 you deposit on this contract, we're going to mint you 1 token. And so how do we calculate this? Well, it's actually pretty simple. We first get the FTSO registry. And then from the FTSO registry, we can query, as before, the price of Ethereum. But now we can query the price of cost on 2 Flare, calculate how much dollars is this currently, calculate how much tokens the user should get, and boom, issue this amount of tokens to the user. So all this calculation is pretty simple, done on-chain, and is really gas effective. So what do? We get the registry as provided by the periphery library. From the registry, we use the same method as before to get Ethereum price, just this time we use cost on 2. And then we just do a simple math calculation, which I hope is right, and we issue some tokens. It's all fully EVM compatible, so all these ERC token, the whole ERC token contract can just inherit from Open Zeppelin library, and boom, we're good to go. Okay, let's see how that works in action. I'm just going to deploy this. So again, how does the deployment work? Simply, as before. So let's take a look at the deployment script. Deployment script is pretty much a classical hard hat deployment script. We import everything. We import the type chain types. Those are directly supported. We create an artifact. We get signers. And then we just deploy the token. And let's just run it. And since we use the default hard hat configuration, we just select the network and run this. Okay. We change the token a bit, so it has to be compiled. We're deploying it. If you're going to play with this yourself, don't forget to get some cost on 2 tokens so you can pay for the gas fees. And as soon as the Wi-Fi gets over it, we're going to get the contract deployed. Come on. Really a empty. It's not the network, it's the Wi-Fi, trust me. Okay, while this is deploying, let's take a look at a bit more involved example, what we can actually do with historical price. So as said before, we can get the current price, or we can see a specific FTSO and see what on this FTSO you can get. So together in this periphery package and in this starter kit, you can also see a price analytics contract. what does this contract do? Well, this contract essentially queries a specific FTSO. So we can take a look at a specific FTSO contract, take a look at the specific pricing pair, and get some additional information from this. So how do we do it? Well, again, we create a function, we get the FTSO registry, we get the token by symbol. Again, the interface is available. And from there on, we can get the current epoch and start building our historical prices. So each FTSO also has a method that gives you historical prices. What that means? Well, that means that you can query historical prices up to 256 historical prices, and you can create a model out of it. So you can create some sort of variance prediction. You can create some sort of more secluded financial model. And in that case, we easily just get the FTSO, get the specific epoch price, and calculate it out of it. And so let's just take a look at how this IFTSO contract really works. So if we go back to the to Flare Networks periphery, we go to Custom 2, FTSO interfaces. We also include this IIFTSO interface. And what's in there? We can get all the existing diagnostic information. So we can see exactly how a specific FTSO functioned, how specific pricing data was compiled. And furthermore, we can also see the data for epochs, the manager, and specific assets. This is a bit more involved data, so we can see how each of the assets was weighted. And if we go to but if we go directly to the not that involved FTSO, we can see the events. So events are useful if you want to listen to this data off-chain. We've got a bunch of applications that are using FTSO as an oracle system to do some off-chain calculations. So you know that this is a decentralized pricing oracles. You know that every 3 minutes you're going to get a new price that is not that impacted by different exchanges going down. So you can listen to a bunch of events. And even more, you can listen to how a specific FTSO submitted the price. When did it submit it, and what did they expect from it to do? And here is the function we were looking at. We can get a specific epoch, we can get the specific epoch price, and then continue from there on. Okay, let's see if the network is a bit better now. We can submit this. This one's still timing out. Okay, that one was deployed. And as soon as we deploy a contract, the next thing you need to do is what? You need to verify it. And as before, you can do this pretty easily with Hardcat. So we just yarn verify, we copy this, and custom 2, and then just check. Okay. This, and then just copy this. Okay, it has been submitted, and it's on. Okay, so let's open it. This is the contract we've deployed. The code is available, and we can easily read it. So I'm just gonna connect with MetaMask, get my address on, and I can easily calculate pretty much anything. And the important function we were looking at was the decimals, the approve, the transfer, pretty much anything can be gotten out of it. Okay, so that's mostly it. So this is Flare. What Flare allows you to do, Flare allows you to build pretty much anything on Flare allows you to build pretty much anything on an EVM compatible blockchain, but you get some additional pricing oracles on it. And from there, well, the path is pretty much up to you. You can do DeFi. We have a bunch of liquidity, a lot of DeFi protocols. You can play around with that. You can do some additional connectivity to other chains. We have state connector coming, and some documentation is already available. So if you want to know more, please find me or Luca at the back of the stage, and we'll help you how to connect Flare to other chains, how to connect Flare to Bitcoin, to Ethereum, gather events, and then use the DeFi protocols on it. If you want to do SocialFi, the block speed is about 1 second. Transaction fees are low. You got all the tooling available. You can use Ethereum account abstraction with paymasters, with stablecoins on it. So you're free to try it, and you're free to play around with it. And yeah, that's it.